Okay, we've got barium hydroxide reacting with hydrochloric acid to produce water and barium chloride. Hey, look, it goes HOH. What type of reaction is this?
Neutralization.
Neutralization. What are our products in the neutralization reaction?
Water and salt.
Water and a salt. Okay. I don't know how far you got reading it, but if you look at it, they've made the concentrations into fractions. You see that? And then they kind of worked around the milliliters. You know, molarity is moles divided by liters, correct? They worked around that. They just left it as milliliters, and they end up with millimoles. Look at it. Read it.
Why did they do that though?
Just simplify it. Rather than take the milliliters, we're doing it without a calculator. Rather than take the milliliters, convert it to liters, and then do the math. They did it with millimoles. How do you feel about that? Strongly. I've had resistance from when I've tried to get kids to use millimoles. Kids are like, no, I'm comfortable with moles, and moles are good, let's leave it alone, Mr. Houston. So we're not going to do it that way. We're going to try it slightly differently. Okay? If you want to study that and you want to use millimoles, power to you. I would rather stay consistent with what we've done and just leave it as moles and liters. Because we're used to that, we're comfortable with it. So maybe you'll want to write down how I do it. Okay? All right. I believe it says it's neutralized, right? If the solution is neutralized, what does that tell us? You have to read some things into this and understand the question. If the solution is neutralized, what does that tell us about our two reactants? Remember the problem we did the other day was a neutralization reaction. Whatever that was yesterday, day before. But the solution was not neutral, was it? Why not, Brian Patrick Henry? You had some, one of the reagents was left over, wasn't it? So it wasn't neutral. So if this solution is neutral, what does that tell us about our reactants, Brian Patrick Henry?
At the base, the moles of the base are stoichiometrically equal.
There you go. Perfect. Even used a big word. You hear that?
Yeah.
That means we have just enough moles of the base to react with all the moles of the acid and nothing's left over. We have all products and it's neutral. Okay? So we know the milliliters of this. We know the molarity of this. We can solve for moles, can't we? Once we know, if we know it's neutralized, then we know the moles of this is in the right ratio to react with all the moles of this. Correct? Okay, how do we find moles? Molarity equals moles divided by liters. So moles equals what? Rearrange it. Equals molarity times liters. And our molarity is 0.120 times, what's my liters? Since we don't want to do millimoles, what's my liters? 0.025.
Exactly.
What's a milliliter? What's a milligram? It's 1,000th of a mole. So we leave this as milliliters, then you end up with millimoles. That make sense? We're not doing that.
You just have to convert from milliliters to liters.
We're not doing that. If you want to do it, you can do it. Last year's class about had kids when I tried to get them to do millimoles. You never heard that expression before?
It's like a pocket.
Okay. How are we going to multiply this without a calculator?
That's an excellent question. They're putting in a fraction. So that means that it's.
You could.
Yes.
How did I do this? Y'all, skip ahead real quick. Take a look at the top of page 8. Are you familiar with those? Those rules for exponents?
Oh, yeah.
Okay. I'm going to change these into scientific notation.
Okay.
Okay? What if I move this to there? What would it be?
Times 10.
Times negative.
Yes?
Yes.
Yes. Yellow.
And let's do, what would be easy to multiply by?
2.5 times 10 to the negative 2, right? So you're moving the same decimal. I mean, the same exponent, but it's just put different decimal.
Yeah. So now, what's 12 times 2.5? 30?
30? Yeah.
And what do I do with my exponents when I'm multiplying?
You add them.
So negative 2 plus a negative 2?
Negative 4 times 2.
30 times 10 to the negative 4.
What is it? Positive 4?
Negative.
Wait, no, you're adding them, right?
Negative.
We're adding adding a negative is like subtracting a positive, correct?
So it's negative 4. Why are you confusing us?
I'm not. I'm asking for clarification.
I'm asking again, and everyone's like, oh, well, he has the kids, so let's not do
I heard 4 over here. That's why.
that.
Wait, hold on. I meant negative. Leave it there right. She made negative.
If she meant negative 4, she should say negative 4.
That's what she.
I meant negative 4, but I said
I
7.
can't read her mind.
Next time try.
Okay. Now we got 30 times 10 to the negative 4. Put that back in standard notation for me.
0.003. 0. You want to keep the
4 places, right? 1, 2, 3, 4. So 0.003 moles.
actually be 0, 0.
That's genius.
No, 00300. I'm saying. It's the same thing, right?
Yeah, how many sig figs we got? 3?
Right.
Is that better?
Yes.
I don't like it. Let's worry about the.
Yeah.
We'll worry about sig figs when we get done. Yes.
The actual AP Chem exam, will they have questions that ask us for morning ones?
No.
No?
Nope. That's just a little trick to find the answer without the calculator. I just showed you another one. Okay?
Sounds good.
Move the decimal so you can get something that where you can do the math in your head. Okay? So we've got 0.003 moles of barium hydroxide. I'm going to write it right here. 0.003 moles. And I'm going to erase. What's the next step? Now that we know the moles of one reactant, what do we have to do? Ratio.
Oh, yeah.
Good. Ratio. So we've got 0.003 moles of BaOH 2. And the ratio is 2/1. So 2 moles, we need 2 moles of HCl for every 1 mole of the base. Okay? With 0.006 moles of HCl.
Now you rearrange the molarity equation to get
Got it.
the liter framework.
So we got 0.006 moles of that. I'm going to erase now when you're ready. Tati, are you ready? I got the thumbs up. Okay, molarity equals moles divided by liters. Now we want to solve for the liters. So rearrange this for me. Liters equals what? Moles over molarity. Okay, moles is 0.006. And we're going to divide by the molarity of the hydrochloric acid was, is that the molarity? Why didn't I label it?
I don't know, I forgot your unit. They'll make.
What?
What?
Finger said what? Thank you. Okay, now we got another math dilemma, since we're not sitting there with the calculator. We're not sitting there with the calculator. Okay, good. All right, we got to take 0.006 divided by 0.15. I can't do that. But you know what I like? I like 60 divided by 15, so let's get there.
Oh, you mean 6 divided by 15?
I mean 60. So let's go 1, 2, 3, 4 places. So it's 60 times 10 to the what? -4. How do I get to 15? 2 places. So it's 15 times 10 to the -2.
Oh, we're not keeping.
So 60 divided by 15 is 4. I can do that in my head.
Oh, not 4.
Times 10 to the, what do I do with the exponents when I'm dividing?
Correct?
So -4 minus a -2. Okay?
All
right. And my units? And my units?
Liters.
Liters.
Now convert it to milliliters. By using-
Okay. So let's put this number back in standard notation. What is 4 times 10 to the -2? What is it?
0.004.
Moving it 2 places.
0.04.
Right now the decimal's here. We're going to move it 2 places. So it's 0.004 liters.
No.
Is that right? No, 2 places. 1, 2. 0.04 liters. How many milliliters is that? I believe it asks for milliliters.
40. Oh, right.
There, you did it.